Today, we're going to run an example using our Arduino Nicla Vision Pro board. This example uses a time-of-flight sensor which is built directly into the board. The goal is to measure proximity using this sensor. Before we begin, make sure that the LED on your board is blinking blue. This means the board is in bootloader mode, and this means this board is ready to use and to be programmed. This example, along with the source code, is also available on the Arduino Nicla Vision product page at the link provided in this video. So now, let's get started and open the Arduino IDE. For this example, you'll need to install the appropriate libraries for the time-of-flight sensor as well as the board support for the Nicla family. For the board package, please click on Boards Manager on the IDE and look forward for Nicla. This package includes all the products on the Nicla family. Make sure to install the latest version of the board package. In the output window, you can get to see when this is installed properly. Once it gets installed, we can go ahead and install the library for the usage of the time-of-flight sensor. Now we will proceed to install the library required for the time-of-flight sensor. For this, we need to go to the Library Manager section and look out for our sensor name. This is the BL53L1X. We were looking for the Pololu version for this firmware update, so also make sure to have the latest version installed for you. On the output window, we will see the installing processing, and once it's done, we could get a notification that it's successfully been installed. Now we can begin with our application. We will first begin to add the libraries required for this project that will include the libraries for the usage of the proximity sensor. It's really important to add this in order that we can use it and we can include it into our application in a proper way. Now, on the setup part, we will begin to add the configuration in order to start using this sensor in a proper way. This will include some of the API applications that are required for the set of the distance mode, the measurement timing budget, and the start continuous for the proximity sensor to be started and used. It's really important to set up the correct clock frequency for the use of the I2C that is communicated to use the sensor. Once we add this part of the initialization and we make sure that the frequency is right, we can proceed with the blinking of the LED that will also help us to reach out a better view of how the detector sensor is working. So we have the proximity read that will give us the value of the measurement about the reading we're having, and we're going to print it also on the serial print output wheels. And we will have the blinking LED just to give us a view and more visual view of how this sensor will work. Now, with everything this done, we can proceed now to upload the code to the Nicla Vision board. For this, it's really important to have this compiled. And for first, when we click on the upload, there is an arrow that's pointing right to the Arduino Nicla Vision part. We will start to compile all this code, and if everything was installed properly, we shouldn't have any problems with this. Once it is compiled, we have to see something really similar to this, and this means that the code is downloaded properly into our Arduino Nicla Vision board. Now we can see in the serial monitor the values of the distance the measurement time-of-flight sensor is capturing right now. So every time we reach or we think that we put something really near into the Nicla Vision board, we see how these numbers minimize and how they get larger as soon as we proxim something or we just take it away from the view of the time-of-flight sensor. This also can be viewed in a more visual way with the linking blade part, but we want to make sure that you can also see it on the serial monitor and that it's working properly as it should be. As we move an object closer or further from the sensor, you'll notice the LED reacts in real time. The blinking speed changes based on the distance detected. Thank you for watching this video.